n equals
to n of x comma y is equal to a into bracket y minus
y notes
for
y notes
y not greater than 0. So calculus of duration series 2. Here we want to solve a problem relating to format principle in optics that states that a light ray will follow the path given by this expression, and we are told to find the minimum path where n represents the refractive index. So the first thing we just have to do is to rewrite this particular expression, that is solution integral where our n of x is this a y minus y naught, and our ds, which has been stated earlier, for getting the minimum point between two, the minimum distance between 2 points, which is 1 plus y prime squared dx. So automatically we are going to replace that one by this 1 plus y prime squared dx. I have said it in the first video, which is the introductory part of the calculus of variation. That is, anytime we have a function that does not explicitly depend on x, our Euler-Lagrangian equation will be f minus y prime partial f by partial y prime is equal to a constant. Where our f is the same thing as a y minus y naught square root of 1 plus y prime squared. So from here, let's represent this by lambda. Let lambda be equal to y minus y naught. So automatically our f will become a lambda square root of 1 plus y prime squared. So now let's solve. Let's introduce everything into this equation. Partial f partial y prime is equal to k. That is, our constant is now k. So now let's bring everything into this particular expression. A lambda square root of 1 plus y prime squared minus y prime. So now let's differentiate. So we are going to have a lambda, then we have to drop the square root on this to give us times 1 over 2. Then we differentiate what is inside, dot 2 this against this into bracket 1 plus y prime squared raised to power half. So automatically then this one eventually becomes k. So we are going to rewrite the expression as a lambda square root of 1 plus y prime squared minus, by the time this one cancels this, we are going to have a lambda y prime squared against square root of 1 plus y prime squared is equal to k. So from here, what is our LCM? Our LCM is square root of 1 plus y prime squared. So by the time we say 1 into this, we are going to have the same expression. So times this, we are going to have a lambda into bracket 1 plus y prime squared minus a lambda y prime squared is equal to k. So by the time we expand this, we are going to have a lambda plus a lambda y prime squared minus a lambda y prime squared against square root of 1 plus y prime squared is equal to k. So from this can easily cancel this. So we are going to have a lambda against square root of 1 plus y prime squared is equal to k. So let's name this as equation 1. So by squaring both sides of equation 1, so we are going to have a squared lambda squared against 1 plus y prime squared is equal to k squared. So let's cross multiply. We are going to have a squared lambda squared is equal to k squared into 1 plus y prime squared. So let's divide all through by k squared by k squared. So automatically our 1 plus y prime squared is equal to a squared lambda squared against k squared. Since we know that we can represent the constant by m squared, which is equal to 1 over k squared, so automatically this expression eventually becomes 1 plus y prime squared is equal to m squared a squared lambda squared. So what we want to get is this y prime. So our y prime squared will be equal to m squared a squared lambda squared minus 1. So our y prime will be equal to square root of, let's write this as a squared m squared lambda squared minus 1. So what is y prime? Y prime is the same thing as dy dx. So our dy dx will be equal to square root of a squared m squared lambda squared minus 1. So from here, since we have dy here and we have y here, so automatically we can bring the two of them together by collecting like time. So our dx will be equal to dy against square root of a squared m squared lambda squared minus 1. So our x will be equal to this square root of a squared m squared lambda squared minus 1. So let's number this as our equation 2. So in order to integrate this, all we just have to do is to represent a squared m squared lambda squared. And how can we do that? Since we know that our cos theta squared minus sin theta squared is equal to 1. This one is equal to 1, just like the cosine, but in the case of cosine it is plus, but in the case of sin and cosine it is minus. So automatically we can represent this. Since we know that our sin square theta is equal to cos square theta minus 1. Since we know this, automatically we can say let a m lambda be equal to cos theta. So if we say this one should be equal to this, so let's differentiate. So I will just have the a m lambda against the theta is equal to d theta of cos theta. These two, they are constant, so automatically they won't be affected by the differential sign. So automatically what we are going to have is just d into what is our lambda, y minus y naught against the theta is equal to, by the time we differentiate this, we are going to have sin theta. So by the time we differentiate this one is also a constant of integration. So what you are going to have is just dy d theta is equal to sin theta divided by this am. So what is our dy? Our dy will be equal to sin theta against am d theta. From our representation above, since we know that our am lambda is equal to cos theta, automatically our theta will be equal to arc cosine am lambda. So by the time we now substitute into equation 2, our x will be equal to the integration. What is now our dy? Our dy is now expressed as this, which is equal to sin theta against am over square root of, this one is a squared m squared lambda squared, and am lambda is already cos theta. So the square will now become cosine square theta minus 1 d theta. So this one is the same thing as sine theta. So we are going to have this one to equal to 1 over am into sine theta against sine theta d theta. So this one we cancel this one. So we are going to have this one to be equal to 1 over am into d theta, which will give us theta over am. That is our x. So let's name this as our equation 3. Equation 3. Since we know that our x is equal to theta over am, what is theta? Theta is half cos am lambda. So let's replace theta by this. So our x will be equal to half cos am lambda against am. So automatically our half cos am lambda will be equal to xam, so that our am lambda is the same thing as cos xam divided both sides by am by, no, we are dividing both sides by lambda this time around, because we have to get this constant out, we have to get their value. So this one is divided by lambda, so that our am is equal to cos xam over, what is our lambda? Y minus y naught. So when x is equal to 1 and y is equal to 1, so our am is equal to, our am will be equal to cos am against 1 minus y naught. So we are going to return this into the equation this, since we've gotten our am. So automatically x now finally becomes half cos into, what is am? Am is this. So we have cos am over 1 minus y naught into, we have lambda here, against, what is this am also? This am is the same as this. So we have this one to be equal to cos am. So since this one is being divided by this, automatically we are going to multiply this one by 1 minus y naught, so that our final expression will become 1 minus y naught into half cos am lambda against 1 minus y naught against cos am. Thank you so much. I hope you enjoyed the class. Subscribe to our channel.